Oh, no, now my mic is on. Hi, everyone. How are you doing? So, for those who don't know, my name is Eyal. I'm usually doing all kinds of software projects for music because I'm first a musician. But today I'm going to do something that's more of like a general C++ concept that hopefully would be useful because it's just heard myself playing for somewhere. I'm just trying this whole thing about streaming on Instagram. I wonder if that works as it should. Looks like it works, right? So hey, Asaf. I see that Asaf Ariel has joined me. I'm actually streaming this on a few different networks, which is why this is always confusing. I'm streaming this on. I was just trying to stream it on Instagram as well. Yeah, I think the Instagram stream should be still good, but how do I get it to not play and not be in my ear? Oh, okay. So hopefully it works. Okay. So let's discuss what it is that we're doing. So I want to talk a little bit about semantics in C++, and specifically copy on write semantics, which is something that C++ doesn't really do by default, and other languages do that by default in some cases. So I think it's going to be important to learn how to implement. And we're also going to write a little library, just a little header only library that you might even be able to like publish during the stream. Yeah, so I am going to load up my IDE, CLion. I'm going to start a new project. Let's call it copy on write. I'm going to actually make a more useful project in a second. And we're going to explore about what the issue is. Why do you need copy on write? Why is that a problem? And what are the solutions, or why is this beneficial to sometimes have that kind of semantics? The only thing I would do with this blank project I just opened, it's right here. I just use a template project. I'm just going to do one thing, which is I'm going to copy from one of my older projects. I'm just going to copy the Clang format and the Clang tidy files, just so that I'll be kind of have like my like the code style that I like. CLion will detect this, and I can just format the code the way I like it without like dealing too much with formatting and everything. Okay, now let's put my screen at the front, and let's start to explore the semantics in C++ in general. So in C++, by default, pretty much everywhere, we get what's called value semantics. What does that mean, value semantics? Let's explore this a little bit. First of all, to test how this works, I'm going to create a debugging class. We would need that to understand what's going on in our project. So I'm just going to create a struct. Let's call it debugger, not debuffer, but debugger. I wish I could zoom on this a bit more. Hopefully it's large enough. It is. Let me know if it's everything is clear and understandable somehow. Okay, so I'm just going to make a class that debugs whatever it's doing so that we can have some understanding of how C++ does things. So I'm just going to do something like std cout constructor, right? And it's basically going to look going to be the same. Here's another one that's going to say destructor. Let's have another important ones. Let's have the copy constructor, const debugger other, and this would do the copy constructor. Let's have another one called the move constructor. So this is going to be debugger other. I don't even need the other. Debugger no accept. This would have the move constructor, And there's a few other ones we can probably use. One of them is going to be debugger operator equals const debugger other. Ooh, something happened in the street next to me. I don't know if you can hear that. But this would be something like a copy assign. And there's another one for move assign. So these are basically all the standard operators. This one, no except move assign. Okay, that's great. Okay, so this is just a debugger class that prints what it's doing. Now the class, let's see that this class works. So I'm just going to put, like, let's say I just put a debugger here, right? Debugger. Let's run this, and this prints. Oh, this is right on my head. Let's move my head so my head is not there. This might probably better. Okay. So you can see underneath it prints constructor, destructor, right? Okay, so this prints constructor and destructor. So let's do something else. Let's do something like O2 other equals debugger, right? Let's see what this does. Okay, so this created the debugger, copy constructor, because here we copied from here to here, and there's two destructors. This was destructed, this was destructed. So this is pretty much the default behavior of C++. In C++ in general, we get value semantics. Like you say, hey, this thing equals this thing, it copies the thing from the source to the destination. Let's make a function like void, do something, and it's going to take a debugger, right? It's just a function. And what I'm going to do is I'm going to call this do something function with the debugger. What does this do? There's a constructor here. There's a copy constructor because here I'm copying the debugger inside. Then the local debugger gets destroyed because it goes out of scope. And then this debugger, the main debugger, goes out of scope and destroyed. So there's a bunch of operations here, right? Now we can, in general in C++, what we do is we try to eliminate all these copies, because these copies and all these destructors, constructors, they can be really expensive. Like for example, if the debugger class wasn't some dumb debugging class, but it actually had like a stood vector of something, right? Each one of these copies, destructors, whatever, could be a huge operation. Like there could be, a bunch of megabytes here for the data. There could be, like the allocation, deallocation. There could be a bunch of operations happening that we might not want when we just want to call the function with the thing and say do something with the debugger. So one of the things that people like to do in C++ is they like to pass by reference. They do this, right? And reference semantics are really useful because now I'm going to call this, and this is super clean, constructor, destructor, right? So the number of operations was very small. It's almost, we literally just copied a pointer here, copied the address of the thing. But what is the problem with this? This is actually a shared reference. Like this debugger and this debugger are literally the same thing. Why is that important? Let's say that we had in the debugger some data member, like let's say there was some int x equals 0 here or something, right? And that means that if this function actually modified debugger, like said debugger.x equals 5, now when we're calling this function, right? When we're calling this function, that means that it might change the debugger, right? It might do something like we can observe this. Like we can stop here with my debugger, with my actual debugger, not the debugger class. And you can see that it says x times 0, and I'm going to go to the next line. Now x is 5. X changed while the function was called. So, I mean, sometimes we have to do what I just did. It's very common practice in C++, but that had as a side effect. That means this function is not clean anymore. It's very different from what was before when I copied it. Before, let's see the previous one. Even though this changes the local debugger, let's stop here in my thing. So you can see that x is still 0. Like this function did not have any side effects. So from the caller's perspective, it was totally safe. However, as we said, there were extra operations here, so it might not be what we wanted. So let's do something else. So one of the things we do very often in C++, I would even wish that in many ways this would have been the default, is we use const reference. So instead of passing the reference like before, we pass a const reference. And this is actually super, super common. Const reference means that you can see this was not allowed. It did not allow me to change it, right? Because it's a const thing. So now this thing has a nice guarantee to it. We can, let's see the output of the run. So when we run this, we still only get constructor, destructor, right? There's no extra operation, so there's no copy like the by value operation. It's very light. This probably should be the default of how you do things. You pass a function. The function itself, like the body of this function, sees it as const. Like you're not going to be able to even call anything that makes modification to the object. But you're a bit limited in the things you can do because you are using a const object which cannot be modified. And if you think about a function that has to return something, like has to actually provide some data to the caller, sometimes you do need a way to return an object. So where does this thing fall? Many times what you would actually want is you want a function that would change the object, but you don't want to change the original object, as that is quite a severe operation. You want something that returns a value that derives from the object. I'm going to explain what this means. This now is going to be more goes into the area of the very basics of functional programming. Not really functional programming like in the how you apply it as to a whole program, but just the very basic concepts of it. So many times, what you want is something that looks like this. You're saying, give me. Let's do something like, let's say, get new, or get modified. That would be a good call set of this. Like really, the call set we want many times is a call set that looks like this. Like it takes a debugger for the input, but it returns another debugger that could be modified, but could also be not modified. Why do we want to do that? Because this would allow us to do everything that we just talked about. First of all, it would allow us to do debugger. I mean, we can directly say this equals 5. I mean, we can do that, but that's not going to help us so much because this would go out of scope. This is a local copy. So that's not going to do anything. What we would want to do is we would want to do something like result equals debugger, and then the result can be changed. That's fine, and return result. So this would allow us to modify the local copy of our debugger thing. I'm going to ignore the thing that it tells me because it says use a move, which I do not want to do. So I'm going to remove this inspection just because even though they're right, it would kind of distract us. So here we're passing a local debugger. We're modifying our local copy, and we're returning the result. Now, this is good because from the caller's perspective, we can do O2 modified equals get modified this, and now this object is safe, right? This object would be totally safe, and there's no problem with the caller. The caller is totally fine. The caller can call a bunch of these, right? For example, imagine if this wasn't just set to X, but this would set something like, this would set plus equals 5. So every time I call this, it's going to be increased. So if I do a bunch of these, right? let's call this function a bunch of times, right? I can call it 3 times or call it in a loop. I can do some logical thing, but this thing is still untouched, right? Let's run this, and you'll see that modified. Oh, what did it do? Result plus equals 5. Oh, what did I miss here? Plus x. Am I not doing what I was supposed to do? Oh, result dot x plus equals 5. Return result. Oh, because I'm actually not doing the copy constructor, because I have my fake copy constructor. Okay. So, but anyway, so the main idea, and we're going to get into this pretty soon when I have a normal class, not the debugger class. But so the idea is that now that we've done this, we can actually call this function many times, and debugger is always safe. Debugger never gets modified, right? We can see if I look at the breakpoint, debugger is still 0. Like, it was never changed, even though this modified function is actually modifying an object, but it returns that object. However, this is very inefficient. Look at this thing. Look at how many constructors, copy constructors, destructors just happen, right? This is very inefficient, and pretty much most front end functional programming languages do a little bit something like this in terms of the semantics, but there's always an optimization that happens above that so that we don't have to call all these. And so there's a question, though, what's the output on optimized output? We can build this in build a release build. Let's build a release build. But I know you'll see pretty soon that it really doesn't matter. The release build could maybe reduce a few operations there, but I don't know if it can do much. Let's run the release build. Yeah, it's pretty much the same, right? This is the release result. It's going to be pretty much the same. Like, it's not this is a big problem. Like, this really cannot be optimized away, because we've asked the code. We've asked the compiler to do all these copy. There's one move assign here. There's one destruct. There's a bunch of destructors. There's a bunch of constructors. So even though in most cases you should be doing like a const reference or something, like, we can still do const reference here. By the way, this would save some of the operations. So this saves some of the copies going in. But it's still not what we wanted. There's no reason to have a million constructors and destructors when we're doing this. Definitely not all these copy constructors, right? We don't need all these copies. Those are pretty kind of bit meaningful, so meaningless. So let's start by explaining what is the pattern that we're trying to solve. The pattern we're trying to solve, or we're going to recreate today, is a pattern of copy on write. Copy on write means that we're only creating. So basically, what's going to happen is we're going to have an immutable object. Like, there's going to be a singular object that would never change. It would never have a modifiable reference to it. We would not allow it. We would only allow this kind of syntax, right? Where you take the thing, even without the const reference, where we take something in, return something back if you want to work with the object. However, when you do all these copies, you would basically get these copies for free, or almost free. And you would not have to create the internals of the class to do that. So Landa says cow. Yes, this is exactly the cow pattern, what I'm about to explain how to implement. So this is not a new pattern. It's been around for a long time. But we're going to show how this would work in C++. So let's break it down. Yeah, so Landa says that I just recently learned every single object in PHP is cow, and this is correct. So I don't know PHP so much, but many languages implement cow by default for objects. I think Swift does that, and a few others, because this helps. I think it really cleans up semantics in many situations, especially when you do something like functional programming. It just helps because unlike reference semantics, I think JavaScript, for example, or Python, they have reference semantics. Reference semantics, like we've seen before, are dangerous. Like you have to protect the thing you're passing in somehow, and it's a little bit dangerous to touch these shared references. I think copy and write in many situations is just more suitable, and we'll talk about this right now. So here's what we're going to do. We are going to start to create something. Let's remove everything here. Okay. What we're going to do is we're going to create something where we're going to start having different semantics. So the first thing we're going to do, I'm going to include, by the way, I'm just going to write this in a very, let's call it simplistic way, and then I'm going to convert this into a template. So there's a question here. Didn't juiceString used to be cow? Cow is copy and write. Or was it std? So the juiceString from the juice library is copy and write. StudString is not copy and write. StudString has very strict value semantics, even though they have another optimization in it called small buffer optimization, where they kind of pre-allocate a little chunk of memory for the for smaller strings. But juiceString did do that, and this is actually going to create something very similar to juiceString in a way where it would kind of force you to have a const shared object. Well, we're gonna run into that. We're gonna talk all about that. But I think some compilers implemented it like that at some point. So I think I'm not so sure what the standard string history is, but I think that it was in the past, it wasn't defined that it had to have small buffer optimization, and to my knowledge, it now is required because there's actually a template argument like on the interface where you mentioned that. Same with stud function and some of these other ones. So I think that now it's part of the interface of StudString, but I don't remember the exact history and the full details. Anyway, back to the semantics of shared objects. So one of the things that people do often is they actually use something that's useful for these exact situations, which is a shared pointer. Why is shared pointer useful? Let's explain this. Let's create this thing called, I'm going to call this a shared class or something. And in it, I'm going to have a stud shared pointer of my debugger class internal. Now, once I have this, let's imagine that when I'm here in the constructor, I'm going to create a new internal equals stud make shared debugger, right? So I'm just gonna create one in the constructor, and the automatic destructor would destroy this. Now let's do stuff with this shared class, right? So instead of creating a debugger, I'm going to create a shared class, and let's copy it a bunch of times. So other equals debugger, O2, I don't know, other 2 equals other. Let's do a bunch of stuff here, right? Let's run this. And there's a constructor and a destructor, right? There's we've basically all these operations were before, right? When we had this, if you remember, let's run this again. When we had this, there's a constructor, copy constructor, destructor, right? A bunch of different operations here. Once we switched to shared class, suddenly all these operations were basically free, right? What there is something that did happen. There is some ref counting that was reduced and added when we did this, but basically this became free. Let's make a function again. Let's make a function called shared class, get other shared class or something, and it would take shared class as an input. And I'm just going to return the input here, right? Let's do O2 new class equals get other shared class from one of those, doesn't matter, right? Look, constructor, destructor, right? We got this for free, basically. We basically got all these operations, not for real free, but we got something way more optimized and way more efficient than the value semantics version of this. So this is very useful. Now, what is the problem with using this little shared class that I made? It's actually not safe. Why is it not safe? Because this whole thing, even though it looks like value, it actually allows you to do something to the object, because I can actually do input internal. I have full access to this, equals plus equals 7, right? And now when I call this, you see all these instances, doesn't matter which one they are. Oh, oops, after the return. That doesn't make any sense. Let's do it before the return, right? Now all these supposedly copies, they're not copies. They actually get the modified value. Like for example here, the original, other, all of them basically touched the shared thing, right? So like I faked myself into thinking I'm creating local copies, but actually it was not a copy. It was a pointer, right? So I basically, even though I made the interface be very performant by wrapping this shared pointer here, I actually basically created the wrong semantics. Like I allowed these classes that seem to be taking values to actually modify internal values, and this is not safe. This is gonna be very hard to reason about. This makes this function not pure, right? So we cannot use it in a functional programming style. So that's not good. Here's where the more advanced copy on write pattern comes in. Instead of doing a shared pointer to the debugger, I'm actually going to have a shared pointer to a const debugger. And look at what happened here. This is not compiling anymore, right? Everything compiles, by the way. I probably should make a mixture of const debugger here. Let's see if everything compiles. Yeah, everything compiles. I still get constructor, destructor. The only thing that didn't compile was this little bit of unsafe code that I was trying to do, internal x. I can read x, by the way, but it's not going to let me modify x. The compiler stopped me. If I'm going to try to compile, it's going to say cannot assign a return value because this operator arrow is now const, right? So this is pretty much how I am protecting the caller from doing that. And this is this is really the basis of the copy on write, because copy on write kind of is we're going to talk about how do you do modifications when you do that, but this interface is the basics of this, like, because now you can create a hierarchy of different calls, and none of them can touch the shared value. All of them are protected. All of them are are more of like, they have this like good guarantees on calls. Okay, so now let's improve this this class so that it can actually do more, so it's more useful, and this would be the basis for a library that we're probably going to publish during this stream. Sorry about that. How's everyone doing, by the way? Hopefully this chat is working. Yeah, so where is it? It's an advanced pimple. I don't know if it's a pimple. I guess you could use copy and write from pimple, but I'm not sure. I mean, under the hood, pimple, like you can, I mean, I guess you can use this as a storage device for pimple. Pimple, by the way, is also an important pattern which I should make a video on. It's called pimple is private implementation, and pimple is useful when you have for example, system-specific things. Like let's say you have a different object when you run on Mac and on Linux or something. So then you kind of instantiate these different private implementation object, but the interface that calls these classes is unified. Same interface, but the user gets a different implementation. So in the pimple, the pimple thing means that we have like some way to not expose the user to what the implementation is. But this is not really about that, even though like technically you can use this. Like when we start to template it, you could use this for that scenario. The real use case is for passing things around. Like it's more of a system to create interfaces that would compose better, especially when you want to do some things that have like functional style interfaces, or especially when you have like these big objects that can be passed around a lot. So let's talk about now how are we going to make this class more useful, and then we can talk about how to template it so it's going to work with anything. I'm going to stick with a non-template version just so that we can reason and talk more about this. So let's keep wrapping this with useful things. So one of the things I'm doing now is that I'm currently creating this new, like this default one whenever it gets created. However, we also, like we said, want a way to modify this object, right? So sometimes we would want to touch this X, right? We would want functions that take the X and give it some other value. But we don't want to do it like this. We want to make sure that the interface that does it is safe for the caller and avoids creating new objects if can be, because like we said before, when we just do this is almost all this does is that it increases the ref count here and copies a pointer, right? So this is almost a zero cost operation, very, very low cost operation. The cost is going to be only when we actually need to create a new object. So here's how we do this. I actually want to make this private, right? I don't want to expose this internal in any way. You should not be able to reach it. So let's make this a class and public, right? So the first thing is this actually means that whoever's going to use this cannot even do input.internal. Like they can't even reach it, right? Even this is not going to compile internal, right? Just calling this does not work. But we do want to have some way to access the internal object. So here's how we do this. The first basic way to do this is we can do something like get, right? We can do like a get function. This would return a dereference version of this. So one way to change this is we can do something like, hey, go to value equals input.get. And this is fine because this is const. This const returns a copy of this value, and this is actually okay. We can probably make a version that even like for a bit extra efficiently that returns a const reference. It's going to be interesting. But this is okay. Now, once we do this, we can change the value. Like this now is a copy of the thing. We can change whatever we want with this because nobody's sharing this anymore. This is a copy. This is good, right? Now we need a way to inject a new copy to the thing. So what we can do is we can just like we have a get, we can have a set. So let's set with a debugger, with another debugger. And all it does is that it says internal equals other. Perfect. Equals std make shared of const debugger and take the thing. And this works only if there is a constructor or a copy constructor in this case that would accept this. So the idea is now we can take this value object, we can modify it by doing let's see, I don't know, let's do something like a shared class output. Let's set the output to take this new value and return it. Okay, this is good. Now let's see what happens. So all of these are, by the way, basically free. The only thing that happens is when I do this. So I'm just gonna not call this, that didn't change anything. This still has constructor and destructor. When I call the function, however, here's what, here you can kind of see what happened here, right? So when I extracted the object, there was a copy, right? Let's, yeah, so here there was a copy in here. And when I created the shared class, there was a copy back, right? This was a costly operation, but it only happened when I changed it. Like, and here's why this is useful. Let's say this was a conditional thing. So if this was like, if only if input dot get dot x is equal then 5, only then do all that stuff. Let's return output, by the way, not input. And otherwise, just return the input as is. And I'm just going to make it if it's bigger than 0, because I know that the initial one is going to be 0. And that means that now, oh wait, what just happened here? Is that actually happening? Oh, okay. So now I still have a copy constructor only when fetching the value, but I don't have these other ones. We can improve that by changing this to be a const reference, actually. Or instead of doing that, you know what? Let's not do that. Let's keep it as it is. Instead, let's do something like have a way to actually touch this value directly. So we can do something like debugger operator arrow. And this would return internal get. And that means this would give us basically a constant way to only touch constant values here. So now we can do input arrow x. Let's see what happens now. Good. Look at this. If we're just reading the value, we basically get only ref count, increment, and decrement. So basically, we don't get any of the operations ever. We can call this function 1,000,000 times now, right? 2, 3, 4, 5, just so that we have a bunch of calls, right? We can pass. We still don't get any significant operations on this class. So the idea is that we get a bunch of these operations for free, because all these return stuff, unless we have to make a change, are almost no ops. This is really important because if you think of like big interfaces where this object gets passed around a lot, right? It could be a lot of calls, and the internal of this debugger thing, this could actually be huge. This would save us a lot of operations and would add the safety. And this is where we want to get. Like, we want to get to this nice interface that allows us to compose things on top of it, but do not be afraid of not just the cost, but also all these operations. Like, we sometimes do not want to have constructors and destructors just called in the middle of our class unless something actually was changing. So this helps us to control that. Let's now work more. So that let's now see if we can optimize the actual modify function, right? Let's not block this modify, but let's just optimize it. So I'm just going to call this function once. Okay, so now when we did this, we still have like quite a lot of extra operations, right? Because we still copied this when we called get, and then we copied the thing back here, right? So this is that's why we get these extra copies. But we don't necessarily have to do this. Here's what we can do now. We can think about ways to create temporary objects in a more efficient way instead of doing get, because get is copying. There's nothing we can do about this. Which is sometimes okay, I guess. One way is we can, we can definitely do this. We can have a const reference on this. That's one way. Yeah, you know what? I'm not sure we want to optimize this copy constructor completely away. What we could optimize, however, is this copy constructor, because there's actually two copies happening here. One was that when we got the internal at first, right? I think this makes sense, but here I think what we did was we actually created another copy to do this. So what we need to make this happen is, I think we need a way to create, instead of getting the value, like the raw value, we need a way to get the to get a pointer version of the value. So that would save us a copy back into the object. So what we can do, we can do two things. One, I can change this to be get value instead of get, just for simplicity, because I like this. I think many times this is might be what we need, but let's start with that. The other one would be something that gives me a shared pointer to a non-const, so a modifiable version of this, and this would be get. And this would return a make shared of the debugger object with the value, which would copy the value, basically. And just like we have this thing, I would also need another version of set, which would have this. So const std shared pointer of debugger reference other, and this would just be can I do this? Can I make this happen without a copy? I wonder. Can I do this? Maybe I can do this. Let's see if this works. I'm not sure this compiles. Let's research if this actually works. So the idea is that this allows me to do this. Let's see if this works. Yeah, this works. Okay, this is much better. Okay, look at what just happened. This is very nice. So let's minimize everything that happens here. Good. So here's what this did. Here's what this did. So there are now two constructors. Right here, we actually got another constructor when we did when we created this, which by the way we're gonna avoid this other constructor pretty soon. We probably can just get by with just one constructor and one copy constructor by combining these operations. So this let us get an actual stateful value, right? Like something like this is a shared pointer to the object that, but that this is actually a new ref count. It's actually a new object. It allows us to change it locally. We could make changes without hurting the caller. This is totally safe. There's no extra operations here on the sorry, there's no statefulness between the caller and the function. Yeah, so this allowed us to have simpler semantics. Now let's simplify this even more. First of all, by allowing me to immediately construct this class with this, so I can also. So let's start by adding something like let's call it like using let's call it storage. So storage would be the pointer to the const, which is this. And we also need something like a using stateful. Stateful something equals shared pointer to the non-const. Stateful. So this would give us a stateful. This would take a stateful. This would be storage. Yeah, this is better, much nicer. Okay, and then we can construct the shared class with a stateful. Right, just by doing internal other. And just for fun, we probably also need a way to construct this with a debugger. Oh, and we probably need a way to also construct it with the arguments of debugger itself. So we probably need a something like this. So template type name args, and this would be something like args. And this would actually create these debuggers with stood forward. Args. So I'm just going to forward the arguments that get passed in. If you have the constructor arguments, pretty much. Yeah, let's see if that works. So that should allow us to do, instead of doing this, we can just do, instead of creating the shared class like this, we can create it here we can do something like O2 output equals shared class with the value. And we can just remove this. And this should allow us to save one more constructor. What did I miss? A bunch of weird templated errors. Do I also need like a default constructor? Probably do, right? Okay, because now I don't have a default. So I would need to have some explicit constructors in there. So I would need to have something like a shared class, const shared class, other equals default, and shared class operator equals const shared class other equals default. Now, so do I also need an explicit default constructor? Is that what I need here? So if I would do this, now what do I need here? What am I missing? What else am I missing? Stood make shared of. Oh, what is this value thing? Yeah, shared pointer debugger. And maybe this needs to appear before. Right constructor arguments. What do I need here? Const stateful, is that correct? If I would do this, would that work? No, right? What does that? Why did it work when I did set? What am I missing here? Let's see. Student make shared of const debugger. Why is it not resolving to this? Why is it not resolving to this thing? Even though I am passing value, which is the shared pointer of debugger, it should be fine, right? Stood shared pointer of debugger. This should resolve to a shared pointer of this, I believe, right? Oh, maybe I also need a maybe I also need this equals to stateful. No, so what is the problem here? What does it need? Why does this need let's see, what does this need? This stateful thing, and it's not resolving itself. Let's see. All right, maybe the template constructor does not like this for whatever reason. Yeah, so we probably don't need to. So maybe what we'll do is we'll make this a more let's make this a more explicit way to do this. So let's make an explicit constructor. So instead of having the main problem is I'm going to have to cancel this somehow, right? And then I would need to yeah, let's not do this for now. Instead of that, then I will just do something like a I will actually take a const debugger without this. Let's start with that, and maybe I'll make a helper that creates it in another way. So debugger, and just create it with this, right? And then okay, this is better. Good. That means I would have to do it like this, debugger. For now, this is going to be simplified in a second, and then okay. And then if we do this, right? What is that? Why that doesn't work here? Call to share classes because okay, because it has to use this, right? So what's wrong here? Oh, okay. Now I need all the default copy constructor and all those. So I would also need to have those. No? What else am I missing? What else am I missing here? Oh, okay, just couldn't create it in place for whatever reason. Why is that? So const debugger. Yeah, why couldn't it create it in place? That's kind of strange, right? So weird why I couldn't do this debugger. Not 100% sure. Structure copy constructors. Okay, but anyway, so the way this works right now, before we'll get into whatever syntax issues that I have here, is let's look at again at the debugging statement. So I got a constructor when I did this, right? I had a copy constructor. So I had a copy constructor when creating the value. I probably should be able to avoid this in a second. So now I'm doing get. This creates, yeah. So let's see where's my second copy constructor that I can remove. So this does. Where's my first copy constructor? Oh, the copy constructor, because I take this and I copy this in here. This is not. This is why I have this one extra copy constructor, probably, right? Let's see. So I create this. There is a constructor, and this is another copy constructor. Okay, and here when I call get, there is an extra copy constructor that probably should not be happening. Let's see why. So let's look at my get function. Oh, I probably can make can I make the get function be like this? Yeah, I can actually do this. So what I need to do is actually I need to remove the const version of the thing. So I think I probably can make now when it's all an internal implementation, I can probably just remove just make storage be the regular share pointer. I don't need the const anymore because I actually don't need this for protection inside of this little thing. It does mean that there is an unsafe way to use this, but I think it would still be better. Like I definitely think I can do this. Do this. Do this. I don't love this. I don't love this. I don't know if I love this. Ideally, yeah, perhaps this copy is actually a better price to pay for the extra safety. We need to think about this. Is it better to pay the copy for the extra safety or not? Because what I can do now is if I make them all the same, that does mean that there is a way to expose the internal pointer. And that means that there is a way to make a change to this that is stateful. I mean, you can, yeah, it's probably not good. No, it's not good. I think let's keep the previous thing. I think the previous thing was better, where I did not allow, yeah, let's remove all the stateful stuff. You know what? I'm gonna say something like that instead of doing this. Yeah. What it would mean is that there's going to be an extra. I mean that would even add one extra copy when you're doing the modification. Like you would copy the value out of the storage and you would copy the value in. I get a comment here that somebody's envying me that I'm not tired. I'm not tired because where I am in Los Angeles, it's now 3:28 p.m. So it's the middle of the day. So it definitely makes sense for me to be not tired. But I can understand how in some countries this is the middle of the night where you should be tired. All right. So let's rethink this interface. So one way to do this is we can expose some shared pointer. Yeah, maybe we shouldn't do this. Maybe we can just expose this by value. The extra value would mean another copy when you modify, like another two copies actually, copy it out and copy back in. The advantage of this is a much simpler interface and much more safety, right? So Yeah, and it's probably better. It's probably better to do that. So yeah, so let's remove all this stateful stuff, right? That was boring. Let's remove all the stateful stuff. It would definitely simplify the interface dramatically if I do that, and that would mean that I can change this to get again, just like we did before. Let's remove this one even. Like this, the interface of this shared class thing, what we're going to call a cow class, or copy and write, it's going to be much simpler. And that would mean that I can do debugger get const great, and then blah, blah, blah. This could just be this. Yeah, so what this would mean, and I should now be able to go back to what I had before, like to the template type name. Args, right? I should now be able to do this again, just to make sure. Sorry, just do it forward. Yeah, I think this should now work better. And now I should also be able to just do this, right? The function declaration, make sure the yeah, and we can also make it like kind of clear by doing something like an explicit one that does the default, so that is very clear what that is. Oh, debugger, so I can just do this, or O2 debugger equals shared class. Dot dot dot. That's missing. Right, what else is missing here? Oh, and I also need specifically to do const debugger. Maybe have an explicit way that where this would be created, I think. While I'm at it, this function gets called a million times, so let's do something like a private function called temp. Yeah, type name args create args. Then we can just keep doing create other. Just reuse that function everywhere. Create stood forward args. This would do create debugger. And this would just be create with nothing. What else am I missing here? Oh, it couldn't do the copy constructor because the copy constructor has to be before that. The copy constructor has to be resolved first. Right? What else? What else? Same call site? Yeah, that's interesting. Why is that? tries to get the, yeah, it does not resolve itself. It does not override this thing. So I think I need to find a way for this to be resolved. Think about this for a second. How do I usually do that? How do I usually resolve these template constructors? Yeah, make it a factory maybe. That's possible. I'm pretty sure I've done that before. Let's see. Let's think of yeah, I think I can actually do that with I think for a second. I'll delete the debugger one. Like, delete this. Yeah. Oh no, I don't think that would work. I think the problem is it tries to it doesn't see this specialization as the first one. I thought it should. I thought it should kind of realize that this this thing is different. Is not this. Yeah, but maybe I'll do it differently. Maybe what I am going to do is I'm indeed going to remove this. If I remove it, is it going to be fine? Good. Okay. So this does work. So this meant that there is a couple of extra copy constructors here, and a couple of extra destructors. And what I could do, I guess, is I could avoid one of these copy constructors. I think that would be the interesting thing, right? So what this means now, if I want to create, but still my call site is pretty clean. Like I can actually even just reduce something like return value. I think I should be able to do this, right? So this can be the call site of something that changes this. So the semantics should be relatively clean. Like the idea is that this can still do, you see this, there's a constructor before we started here. Then when we call the function, nothing happens, but if we make a change, then we have to copy it out and copy back in. And we can probably save that by what I did before with this creation of the what I called stateful class. This would be an optimization, right? Like basically fetch a pointer here, modify it, and push the pointer to avoid the extra copy. So we only have one copy. We should be able to do this, I think. Let's go over this again, see what did I do wrong. Now that I have this interface, right? The idea was that let's see. So maybe the problem was I had some conflicting constructors. I forgot what the bug was before. Let's try it again. So I want to do something like stateful equals to shared pointer of debugger. And I should be able to do something like get state or something, and this would return const. This would return a std make shared of debugger, which would take the value, and then I should have like a void, another set function that would take or even maybe now even just a explicit construction. I think that probably would have been the problem here. So if I would have something like a stateful other here, and I should be able to do internal equals other without copy. I think this should work. I think that those two should be, I should be able now to do get state, change this with an arrow, and then return it like this. Let's see if I'm right. Good. Okay, so this is the a more optimized way to do this. Maybe we should make this the default, because this is a more performant way to do this. Right here, we got a constructor, only a single copy constructor when we've made the copy. And then we got two destructors because we actually had two objects, and I think we only got them here. So if I'll go here, and I'll look at the console before we exit, so there was no destruction happening until we actually dropped all these values, right? And now this is really nice because let's say we, you know, let's make this one, you know, this is very much a functional programming style. Like this thing would modify this, this thing would modify this, right? Let's see what this does, right? You can see there were 3 copies, right? So when we finished evaluating these functions, we have now 4 copies. There's no destructors yet. We just did the 4 copies, but we didn't do any copies going in and out of the function, right? So these could be, if one of these functions did nothing, we would still have almost no operations, just sharing the same pointer. And you see this one had. There's still a bug with the actual debugger class because there's no like this copy constructor. It's actually not doing copy, so it needs to be something like not this one. Sorry, the debugger thing. The debugger class is actually because it's a hack class, so this probably needs to do something like other, and this would be something like x equals other dot x. Yeah, so yeah, we really need to actually do something useful because we've done custom copy construction here. You know what I'm going to do? I'll keep this debugger class because it's nice that it's so clean and does nothing. And instead, what I would do is I would have a class that has this class, like something like struct shared, you know, let's call it stateful debugger. And this would have this and the debugger, and then we just work with default things, and this would work with the stateful debugger. Right now, instead of doing all this stuff, I'm just going to start now doing what I was supposed to do at first, and I'm going to make this a template type name T, and all of these should just be a T, 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 and T. T, T, T everywhere. Good. And now let's change this name so that it has a better name. Let's call this cow, or copy on write. Maybe I'll make it copy on write, copy on write, copy on write. Okay, that's great. Now let's make this a copy on write off, how do I call it? Stateful debugger or something. See what happens. Good. Okay, then this would actually work because the stateful debugger is now nicer because it's both does this printing that we just did, so that's useful. But then there's actual copying that happened. Yes, look at this. So let's take a look at these variables. So the initial one still has 0. It was never modified. It's an immutable value. Second one has 5. Third one has 10. The other one has 15, right? Another value. So this basically gave me full value semantics, but with reference sharing, because if this internal function had, like we did before, here's the value, right? I could do something like only if the input is bigger than 5, right? Or sorry, if it's smaller than, let's do smaller than 5. If input x, right? Because I can access this value directly in a way without creating copies or without modifying, right? And otherwise, just return the input. So let's do this again. And notice here, there was just one constructor and one copy. All these other ones, like here's what happened, right? First one, notice that it was too small, increase it to 5. So now this is a different copy than the original. Second one is also a 5. And if you look at the pointers, you'll see that these are the same address. So the class automatically knew when to create a new thing and when to just keep holding the same thing as a pointer. And this is really where the smartness of copy on write comes in. If you have all these copies kind of thrown in where most of the time you're just sharing, you will have a great deal of efficiency by working with this copy on write thing. Well, let's see if we can clean it up a bit. So first of all, let's do something like using cow templates type t, using cow equals copy on write t. Let's have cow everywhere. Look at this beautiful cow. Good. And I think we got something that is way more efficient than anything else we've done previously. The only thing that would beat this in terms of efficiency is if we pass by reference and would protect this. We would pass everything by reference and we would know that nothing holds on to something that could be changed. Here we don't need to worry about this because, like you can see, once we made a change to this, we have another copy, and this original value can be safe, and also it can be recalled as well. Like if this was an undoable operation, like let's think about these like as in something like Photoshop or Premiere or DaVinci Resolve. Like this would be a bunch of like really heavy operations. This would hold the undo stack. We can just save them in a vector. Like I can have a vector of this object and save every single step of the operations, and I would have the entire state. And to make it interesting, you can also have cow objects store other cow objects and create a graph of these different objects where, again, each one of them only gets created on demand. So it's not bad, right? It's not bad. I think that we do need a few more helper functions probably to use this correctly. Like we probably need something that would be called like make cow. I think it's also going to be useful. Like if we have like a more complicated object with a bunch of arguments, we could probably use a make cow and create this with the different arguments, similar to how we use stud make shared. So I would need something. Okay, so the comment says, cow is strong if you don't need to store the addresses of the ILD data, which why for string it can be counterintuitive if you store iterators like string view. I'm not sure I understand. Like the idea with this is that you don't get the pointer for the data. You have no way of getting it. I'm not exposing to this in any way. The idea is in cow in general is that it seems like a value. Like the idea is that as far as you're concerned, it's a value. Even when I'm giving you this get state thing, like the copy, basically, maybe I can call it copy. Maybe this would be better than get state. Because this actually creates a copy, right? Yeah, let's call this copy. This is nice, copy. Much more expressive than get state. So the idea is that if you work with this, you have no idea what this is. You don't touch this pointer. You don't like. You could use this now with a string, right? Like let's use this with a string. So we'll see what this does. Let's remove a bunch of these functions, and let's say my main function is a cow of stud string. Great. So you should be able to do. Oh, and for this, I probably also need the little helper. So let's have my helper called template type name args, type name args, type name t. Yeah, let's start with that. My t type args. So that would mean, let's call it void make cow. We're gonna create a cow. So this is gonna take args. It's gonna take the arguments. Then we're just going to do this should return me a cow of t. And this would return a something that takes a t with those arguments. Forward args. So I should be able to do something like, instead of cow, I should do something like make cow with this and call it hey. And then I can use another one. So let's call it first, or x. And y would be hello. Right? So I should be able to do this, and I can still access, yeah, so I have hey, I have hello, all of these, both of these strings got created, and I should still be able to use a string view with this, because I still have access to the const value of the string. Let's see, string view, let's see if I remember the syntax of string view. So let's ask for a string view. String view. Can I just do in general? If I had a std string z, I should be able to do this, right? Just create this with this. Is this how it works? String view a. That should work, right? Let's see if I remember how to use string view. Yeah. So this is z. Yeah. So I should now be able to create the same thing, but create it with some portion of this. So to do this, I might need a bit of a help to, I might need a way to grab the internal const object. So let's add a operator star const return internal. I need to make sure I'm never allowing this to be null, by the way. So there might need some extra protection here. This should be a reference. And then this would mean that I can, just like I created the string view, I should be able to create the string view from this, right? Yeah, so here's a string, here's a view, right? I can create a view from this. So there's no problem using a cow string to create a string view. It's totally fine, in my opinion. If you wanted to create a stateful version of this, right? A stateful version that would modify this, because I think this won't let me do anything, right? Will this let me do a equals other? Can I do this? Oh, but now it would assign something else. Can I? Yeah, it didn't change the original. If I can do, let's do, can I do this? B. Yeah, it's not gonna let me do this because it's const. So the comment is no, but if you change a char inside the string would be invalidated and the string view is still, yeah, but I don't think this would allow me to do this, right? Because it's a const string. I think if this was this, right? How do I even change something? How do I even change something with string view? Because the pointer to this cannot be invalidated. Can I even change something with string view? Can I modify this? I don't know how to, I'm not really sure about the string view semantics. Yeah, so I'm not 100% sure. But anyway, the idea is that this is basically just like working with a const object. So no, but the original string the view is pointing to, the reason why the standard is disallowing cow strings because the iterator, so yeah, but this is not a cow string. This is a cow object that could hold a string. The string itself is not cow. So the string itself cannot have pointer invalidation. The cow object that holds a string, but that's true for any struct that has a string. Like just for example, I could, I could also just have something like struct, my data and have a stood string, blah in it, right? And if I would pass this to a string view and then delete this somehow, right? Then whoever is viewing blah would be damaged. So this doesn't stop that from happening. It doesn't stop you from like global management of your objects to fail. And it also doesn't change how string is stored. It's not a cow string. It's a cow object that has a string in it, if that makes any sense. Yeah, but anyway, so I think you understand the point. When we did this hopefully has helped us create something that is much nicer to reason about. We might need a few other helpers here, but we can start by making a library and maybe write a few unit tests and see that we know what we're doing. How's everyone doing, by the way? See, mostly see engagement from Alanda on Twitch, a little bit on YouTube, a little bit on Facebook. I know people are watching this on Twitter. People are watching this a few places. Oh, that's interesting. Huh, it's so weird. My YouTube is showing the wrong title. I wonder why. This should not be the title. Oh, never mind. Huh. Thank you so much. I'm so happy that this is helping. Hopefully this is useful in some way. And next thing I want to do is make this a proper library. And we are about to see. Why. Okay, so let me, now that we've got the basics to the code, now we're going to properly do the code. So I'm going to start a new repo. I'll copy the code from there. So I'm just going to go to my GitHub. I will make a public repo called, what I'll do is there's a template I'm using called juicy make repo prototype, but I don't need most of the stuff from there. I'll just make a new repo with nothing, maybe with a MIT license thing. So let's make a new repo. I'm not showing you all of this because it's got my personal stuff in there, but there's nothing secret. I'm just going to GitHub, creating a new repository. It's going to be called copy on write. A copy on write cow template helper in C++. Template, not helper, template. Yeah, template, template header only C++ library. It is public. I'll add a README. do MIT license. Fantastic. So now that I have this beautiful repo, I'm going to pull my empty repo. And I would copy this clean format, clean tidy, all these 4 files. I'm going to copy them in here. Perhaps the code can be, let's call this something like include. No, people like that form for whatever reason. And I'm gonna also make this. I had this smaller. I know people like this. It just drives me crazy. I might just do include. It drives me crazy that it's inconsistent like that. And then examples or example. And what we need in the include folder, we need to call this copy on write. This doesn't need main. This doesn't need all this debugger classes. All it needs is memory. And maybe I would put it in a namespace, something like a namespace EA. That's what I usually use. And here, here are my CMake file. Let's create a library for this, so it will be easier to include in CMake folder if you need that. So let's do something like add library. Let's call it copy on write. And it is an interface library because it's just a header. And this thing just has a target include directories, which is for copy on write interface, and it is it's just here. It's just called include. Oh, what I might do probably better is if I would inside of include, I would make another directory, call it copy on write. Actually, then we probably don't need include. So let's just make a copy on write thing in here. Yeah, is it correct? No. It is better to do it like this. So I'll put it here, copy on write. I'm going to copy on write in here. It's a weird directory structure, but I've seen a lot of libraries do that because that lets me do this, have the include thing in the include path. The example would probably be optional, but it would start with this. Let's make a CMake file for the example. Basically, all the example does, add subdirectory example, that's good. Include, yeah, okay. And then what this thing has to do, I probably don't need C+20 for this. I can probably get by with C+17. Okay, and then this would do something like add executable example main.cpp. It would target link libraries, example, private, copy on write. This is really all this has to do. And then what this needs to do, you don't even need, the main doesn't need this before because we just copied it. And it just needs to include copy on write, copy on. That's why, by the way, why we did this little interface thing, so we can do something like this: copy on write, dot h, and now we should have EA make cow and EA make cow. Good. So this was like our initial refactoring this into a library. So now main is completely separate from this library. This library can just be included. It doesn't belong to any project target, so we can probably do, just to help CMake see this, so we can go here and say target sources, copy and write interface, include copy and write at h. Yeah, because I think this would help CLI and see what's going on here. Good. So this is our library basically. It's a single header. For some reason it says memory is not used, but it is used because I'm using std shared pointer. Not sure why it says it isn't used. Anyway, this is now, and main just includes that. Main does not need to include this. Maybe this is the issue, probably. No? Interesting. I'm happy for the CMake support. And yeah, so we can probably commit this just so that we can you know, get a starting point. So let's do something like, oh, I also need a git ignore. Here we go. There's no git ignore here. So let's go to one of my previous repos. One of the things I always put in git ignore. Git ignore is a file that ignores, you know, whatever you put in locally, ignores it from being committed. So one of the things I do often, you know, is I have a git ignore file that has stuff like the IDE folders, like the auto-generated IDE folders in the build folder. Okay, good. Oh, now when I'm committing, I can see just the files that I meant to put on the git. So initial commit, added initial cow library file and example. Okay, so this is our initial commit, and we probably need to do a little bit of more work, both to improve the library itself and to perhaps add a few unit tests. I think testing this would be useful. So, and also kind of teach you and me about the proper way to deploy such a library. Notice, by the way, this is kind of fun. I made the CMake file, and we're probably going to I'm going to make this fetchable in a nice way pretty soon, so that you can use something like CMake fetch content to just grab this, which would probably be an example we're adding as well. And then I would make this example project optional. So if you just use this, you don't need to build the example. You don't care about it so much. But I want to do it in a way where, because first of all, this is header only, and you can just include this header. Like, you don't need to care about the build system. Like, there's no build system things here, and there probably won't be. But I do want to make sure that if you kind of load this as a developer that wants to observe what this does, you should be able to to have at least a working example with CMake or something like that. Like we just do, that builds an example, and I don't want to just force you to reconfigure a new project to test with this. Do you ever wish we had a standard package manager in build with C++? I mean, yeah, that sounds good. I know that Rust has something called blanking out on the Rust Cargo. Cargo is the Rust package manager, or pip for Python, or npm for JavaScript. I think those are useful, extremely useful. Like there's something nice about having some consensus of how these should be configured. Yeah, it definitely would be nice to do, but it's not like those don't exist. Like I can fetch content right now, things, or I can use, there's more elaborate package managers. So, so there are solutions for this. They're not all, there's some argument which one is better and should you use this or should you use that. Okay. Let me see what's going on here. Okay. So what I want to do is I want to configure this project to also have a few unit tests, and this would help us to get a good view of what this looks like. So just because I hate, I don't like to memorize syntax, I'm going to open another project that I have, which is like the juice CMake repo prototype. Not this one. This is a fork of that repo. Should have that repo somewhere. This is just and I have a way where I helped. I saw how. Yeah, that's because I've already configured the testing sphere in that. So this is just a public repo that I have that's relatively popular. Here you go. So there's this thing here about how to set up the unit test runner stuff. So I'm just going to copy this just because it is useful, and I'm just going to use this to write my new tests. So I'm going to add subdirectory tests, unit test runner, set properties, include ctest is great. Oh, right. I need to have a file to add a way to actually find this. So I'm going to steal it from my own repo. CPM and find catch 2. Do you use CMake Plus? I don't know what that is. What is CMake Plus? CMake Plus. CMake Plus plugin for JetBrains IDEs. Extend CMake support. This is kind of cool. What is that? Ooh. Extend CMake support, highlighting. Wow. This is awesome. How did I not know about this? Costs $5 here. Yeah, I'd pay them $5. This is awesome. Wow. This is very cool. Okay, I'm gonna buy this when I get off the stream. This is pretty awesome. Thank you for telling me about this. I did not know about this until this second. It is very good. Okay. All right, so I'm going to get off the stream for a few minutes, but before I do that, let's do a couple of things. First of all, let's see that I can actually do some sort of unit tests. So I just want to make sure that I have so much fun that I have a repo to copy this stuff from. Blah, 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 blah. this. I just need to add the CMake path so that it could find catch2. Oh yeah, I need to get the latest version of CPM and not the version in the repo. I have to update the repo. CPM should have that, yeah. Oops, where am I? Open in Finder. Huh? That's weird. Okay, let's copy that. Good, so here we go. So there's a juice thing that's not needed. Let's, I might not even need to, do I need to create the test runner here? Maybe. I guess I can. Let's do something like add. Instead of doing that, let's just do add executable. All right, good. So now I have perfect. Perfect. There we go. So I have a thing called unit test runner. It's still has tests like the dummy tests. So let's make sure it has actual tests. And these tests would have I don't need these. I just need to link the test runner with copy on write. Oh, I think I also need to call enable testing here. Is that I think I have to call this from the root repo if I remember, for the root CMake, if I remember correctly. And this would just be, let's call this test instantiating cow. Cow int. Or whatever, O2 cow equals a cow. Or make cow int 23. So this isn't testing much, but it is something. Yeah, this runs the test. And I should be able to also, yeah, it does see that it's a catch thing. Let's see if it's going to discover this test. If I, because it didn't discover the test. Let's see. So the question is, have you tried both catch2 and gtest? What do you look about catch? You know, I don't know. I've tried gtest a bit. It seems very similar to me to catch2. I'm not sure honestly what the big differences are. It's sort of like slightly different syntax to do the same thing. Maybe there's features that I'm not aware of, right? So I can't tell for sure which one is better. The one thing I needed to check is, do I need to run all C tests to make this work? Oh, okay, good. So now I did discover the test. You see there's a test here called test instantiating cow. And it passes because there is no, let's test just for fun. Let's do, what's the syntax for actual testing? It's called require. So I need to here go and, for example, require. Let's make it fail cow. Cow equals to 11, right? Let's make this fail. Right, this fails, right? So this says that if I run this from here, see, I got an error on the test. If I make 23, okay, this works, right? This doesn't test much, but this is a test. So this would be my basic unit test flow. Let me start by committing this. So added initial catch to test mechanism. So there aren't any actual, this test doesn't test anything of importance, but it is a test. Okay, I need to get off the stream. I might come back to continue this a bit later.